Hello students, welcome to another edition of Math with Mr. Vaughn. Hey, today we're going to be looking at a very important theorem that will help you in a lot of different applications, not only on the GED, not only on tests, but also in real life. Alright, so today our objective in Unit 4, Lesson 2 is that students will be able to use the Pythagorean Theorem to find the measure of an unknown side of a right triangle. All right, so that's our goal today. Okay, so first of all, what's a right triangle? Well, to understand what a right triangle is, you have to understand what a right angle is. A right angle has nothing to do with it being right or wrong. Right? Right angle simply just means that it is 90 degrees. It's a perpendicular angle. Okay, you see these all over the place. Right, so this angle right here, this little box here is the symbol in math that we use to designate that this is a right angle. It's a perpendicular angle. You see how this line and this line are perpendicular to each other? They're at 90 degrees. So we have a right triangle here, and we have a right triangle here as well. So we're going to do two different examples today. All right, so let's start off with this one here. So this one has a height of 5 inches, a base of 12 inches, and we don't know what this length is here. And by the way, this is called the hypotenuse. Hypotenuse. The hypotenuse is always the side opposite of the right angle. So if you just take this right angle, you look opposite, there's the hypotenuse. The hypotenuse is also always going to be the longest side. Okay, that's two important things to remember about the hypotenuse. Okay, so we don't know what our hypotenuse is. By the way, these are called the legs of the triangle. You have the hypotenuse and you have two legs, just like you have two legs. All right, so how do we find this missing side, the hypotenuse? Well, we need the Pythagorean theorem, and this theorem works whenever we have a right triangle and we're missing one side. All right, so here is the Pythagorean theorem in all of its glory. Pythagorean theorem is a squared. What do I mean by a? A is just one of the legs. Okay, so we'll call 5a. A squared plus b squared. So it's the sum of the legs squared equals the hypotenuse squared. Okay? So A and B just refer to the lengths of the two legs, and the C refers to the hypotenuse. By the way, the A and the B are interchangeable. It doesn't matter. 5 could be A or 5 could be B. 12 could be A, 12 could be B. It doesn't really matter. However, it does matter. The hypotenuse has to be C. All right? So let's take a look at this triangle here. Okay, we got a squared plus b squared. I like, just my personal preference, I like to use b as the base leg. All right, so if I'm looking at this triangle here, my base leg is going to be 12 inches. So that means I'm going to let a be 5. All right, so I'm going to use this theorem. So I got 5 squared plus my base squared, which is 12. And these are all in inches. And that's going to be set equal to c squared. Now I don't know what c is, so when I don't know something, I just put a letter there. All right, so there is my Pythagorean theorem for this triangle, for this right triangle. Okay, so now it's just a matter of doing some operations. Okay, so 5 to the second power, do you know what that is? Okay, this basically means 5 times 5, not 5 times 2. All right, so this base is being multiplied by itself 2 times. So 5 times 5 is 25 plus 12 squared. So 12 times 12, for some reason we all know what 12 times 12 is. 12 times 12 is 144. Okay? And that's going to be equal to, well, we still don't know what c is, so we'll just leave it as c squared. Okay. So now we have 25 plus 144. We can go ahead and add those two. All right, so 25, what's 25 and 144 plus 25. So I like to count by tens. So 144 plus 10 is 154, plus 10 is 164, plus 5 more is 169. All right, so I get 169 equals c squared. All right? Now this is where the rubber hits the road. I need to solve for c. I need to get c by itself. I need to get rid of that little exponent. Okay, this is not ready. So what I need to understand is I need to know what the inverse of a square is, of a second power. What's the inverse of this exponent? Well, the inverse of a square is a square root. Okay, it's kind of easy to remember because they both have the word square in it. Okay, so remember, inverses are very important in math because they undo operations. So if I want to undo that square right there, I simply apply its inverse. Okay, but the golden rule of algebra, do unto one side as you do unto the other. So I have to take the square root of both sides. All right, so what's interesting is the square root of c squared. Well, what is the square root of c squared? Well, let me make a demonstration as to what that would be. Let's take, for example, the square root of 4 squared, right? So instead of c, I'm going to put a number in there just to help you out a little bit. So 4 squared is 16, right? And I still have to take the square root of that. Well, what's the square root of 16? What number squared gives you 16? 4. All right? So notice what happened from the beginning to the end. What did I lose? Well, I lost my square root symbol and I lost my square. Why? Well, because they are inverses of each other, and so they undo each other. So if I want to undo that square, I just simply square root it, and the result is that both of them disappear, both the square root symbol, the radical, and the square. So I simply end up with c. So I'm going to go ahead and put c over here. So c equals the square root of 169. So what times itself, what squared is 169? Do you know? Well, if you need to use your calculator, you can do that. You can just simply type in 169 and then take the square root of that. Or do the square root and then type in 169. And you'll find that the square root of 169 is 13. And that would be 13 inches. Okay? So c equals 13 inches. Okay, and so what I did, just so I could prove this, is I drew both of these triangles to scale. In other words, this actually is 5 inches, and this really is 12 inches. So here is going to be the ultimate test. Let's see if that hypotenuse actually is 13. Well, let's find out here. Is that 13? I don't know if you can see that on the video, but that, my friends, is exactly 13. All right? So the Pythagorean Theorem works. Okay. So, how about this one over here? This one's a little bit different. It's a right triangle, that's the same. And I have the length of one of my legs, and I know the length of my hypotenuse. Right? The hypotenuse, remember, is the opposite of the right angle. It's the longest side, but I'm not given one of the legs. So how do I find the length of the missing leg when given the hypotenuse and the other leg? Well, remember, as long as I have two sides, I can find the third side, whichever side that is. Okay? So let's go ahead and apply the same procedure as I did over here. Okay, so my hypotenuse is 14. And here's A. So A squared, I don't know what A is. So I'm going to just go ahead and leave it as an unknown. A squared plus B squared. B squared is 8 squared. And again, I could have gone 8 squared plus B squared. It doesn't matter. The two legs are interchangeable. Equals, now it equals C, but this time I know what C is. C is 14. 14 squared. I have to square everything. Okay. So this is a little bit different, isn't it? I can't just simply add these guys up like I did over here. So what I need to do is, but I can take the square of 8. 8 squared, well, 8 times 8 is 64. Equals, I'm going to bring down the A squared plus 64 equals 14 squared. Now, what's 14 squared? Let's see here. 14 squared is 196. 196. I could have done that by hand, but save us all a little time. All right, so now how do I get A by itself? Well, first of all, I need to get rid of that 64, don't I? Well, how do I get rid of a plus 64? You just subtract 64. Watch this. Minus 64. And look what happens to 64. It disappears. If I got $64 and I lose $64, now I have $0. Okay, but golden rule is I got to do that to both sides of the equation. 64 minus 64 is going to cancel. Okay, and so I'm left with A squared equals, what's 196 minus 64? Well, let's see. 6 minus 4 is 2. 9 minus 6 is 3. And 1 minus 0 is 1. So I get A squared equals 132. Okay, now remember, I need to get A by itself. That's the goal. The problem is it's not quite by itself. I have that square. I have that exponent there. Well, do you remember what the inverse of a square is? You got it. It's a square root. All right, so I'm going to take the square root of both sides. Remember, we got to do it to both sides. Okay, so the square root of A squared is, you remember what happens when I square root of square? I just end up with, this is called a radicand. I just end up with the radicand inside. So the square root of A squared is A equals, now what is the square root of 132? Well, let's see. If I have a calculator, I can just do that really quick. Let's say I don't have a calculator. What's the square root of 132? Well, I could find that out by, let's do that here. I do know that, I know the square root of 121, right? Square root of 121 is 11, correct? And I do know the square root of 144, which is 12. But what's the square root of 132? 132 is somewhere between 100, about halfway between, huh? 121 and 144. So if you were to estimate what is the square root of 132? Well, it's about halfway between 121 and 144. I'm going to say it's about 11.5, approximately. All right, you can approximate these things. Let's see how close our approximation is. All right, so let's see. The square root of 132 is 11.4891252931. So how about we round that to 11? Want to do 11.49? How about we just round it to 11.5? 11.5, and that's inches. All right? And that was right on with my estimate. All right, 11.5. All right, now here's the ultimate test. Is the length A really 11.5 inches? Well, let's find out. Let's see, I got too many things in my hands here. Let's find out. You be the judge. Got that right there. Is that about 11.5 inches? It sure is. It's right between 11 and 12, huh? So it works. So Pythagorean Theorem is useful for all kinds of applications. We didn't go over any real life applications here, but in your homework you're going to have some of those, and you'll find that the more you learn about math, the more you use it. All right? So I hope you enjoyed this video. If you'd like to receive more videos in the future, be notified. Make sure you subscribe to my channel. Until then, may God richly bless you.